June 2025. In just 4 nights, an alert from the Atlas telescope detected a brilliant speck tearing through our solar system at nearly 152,000 miles per hour, faster than any known asteroid and unmistakably interstellar in origin. NASA swiftly confirmed the signal. This was 3I/Atlas, only the third object ever observed from beyond our sun. But what unfolded next shattered every established pattern. Its luminosity was far too intense for its size. When astronomers traced the trajectory back toward the inner galaxy, they discovered eerie deviations that no comet could possibly explain. Some scientists now suggest it might be more than mere rock and ice, perhaps a probe, a warning, or even a message. So what final signal did 3I/Atlas truly transmit? And why is the scientific community on high alert right now? The Atlas night crew in Chile maintained their vigilant watch over the data stream, searching for anything anomalous. On June 25, 2025, the automated alert system flagged a dim, rapidly moving point of light, one that matched no known asteroid or comet in existing catalogs. The timestamp registered 3:17 Universal Time Coordinated. Within minutes, the system classified it as a top priority candidate, initiating a cascade of follow-up observations. For the next 4 nights, every clear hour became precious. Each telescope pass added another position to the expanding trajectory plot. By June 29th, the object's motion was undeniable. It was cutting through space at a velocity that gave even veteran observers pause. The discovery window was razor-thin. The dense star fields near the galactic center nearly concealed its trail. Only by merging Atlas's rapid response pipeline with archival images from the Zwicky Transit Facility did the team realize the object had been visible as early as June 14th. Nevertheless, the official detection window, June 25th through June 29th, represented the narrow margin between a historic discovery and a missed opportunity. With each passing hour, the object gained distance, its path carrying away from the inner solar system. Slack channels lit up and late-night calls multiplied as the Minor Planet Center received the initial alert. NASA's confirmation arrived in less than 24 hours. For the Atlas night shift, the realization crystallized. They had just captured the third interstellar visitor ever witnessed, and time was already running out. Orbital dynamicists at the Minor Planet Center began processing the numbers the moment positional data reached their systems. The trajectory wasn't merely unusual. It was mathematically impossible for any object gravitationally bound to our sun. The path traced by 3I/Atlas forms an open hyperbolic curve with an eccentricity far exceeding 1. In simpler terms, it's traveling too fast, over 152,000 miles per hour, for solar gravity to ever recapture it. Astronomers call this hyperbolic excess velocity, a speed so extreme that even as our sun attempts to pull it inward, the object simply resists that gravitational tug and continues onward. The calculations point back toward the constellation Sagittarius, near the dense core of the Milky Way. This direction isn't coincidental. It suggests an origin somewhere deep within the inner galaxy, far beyond our scattered disk or even the distant Oort cloud. The object's inbound vector and velocity eliminate any scenario where it could have been ejected from within our solar system. No known planet or previously cataloged object could have imparted this magnitude of acceleration. Astrometry teams executed repeated orbital solutions, each one confirming the same conclusion. The object's speed and angle indicate it's not merely visiting. It's passing through, never to return. The previous 2 interstellar objects, Oumuamua and Borisov, displayed similar hyperbolic paths, but 3I/Atlas stands apart due to its sheer velocity and the precision with which its orbit can be determined. Every additional data point strengthens the case. This is an interstellar traveler, a messenger from a realm we can only conceptualize. Photometry teams at the Vera-C Rubin Observatory worked through multiple nights, measuring every photon emanating from 3I/Atlas. The data simply wouldn't reconcile. For an object with a nucleus measuring just over 11 kilometers across, the brightness was extraordinary. Even before the comet's closest solar approach, its coma extended nearly 24 kilometers wide, a cloud of dust and gas that typically dims as it expands. Instead, 3I/Atlas gleamed with sharp, almost metallic brilliance. Albedo, the technical term for reflectivity, became the topic of intense discussion. Most comets in our solar system reflect only a few percent of incident sunlight. This one reflected far more, placing it in the category of fresh ice fields or polished metal surfaces, not dusty rock. The Rubin data, cross-referenced with observations from Atlas and Gemini South, confirmed its outlier status. The surface appeared so luminous that some photometrists speculated they might be observing a hollow shell, or perhaps a crust composed of unfamiliar ices. Others suggested a highly porous structure where sunlight scattered across countless microscopic surfaces. Yet no natural comet or asteroid in the historical archives matched this precise signature. The nucleus was too large for this level of brightness, and the coma too uniform for a typical outgassing event. Each new observation deepened the enigma. If the surface was genuinely this reflective, it would necessitate a fundamental rethinking of how interstellar objects endure the journey between stars. The only path forward required high-resolution analysis, something only the James Webb Space Telescope could provide. The James Webb Space Telescope's observation window opened as 3I/Atlas cleared the sun's glare, granting astronomers their first opportunity to investigate its true nature. The mid-infrared instrument, MIRI, mapped the object's thermal emission throughout a complete rotation. Instead of chaotic temperature fluctuations or localized hotspots, typical indicators of jets or vents, the data revealed a stable, nearly uniform thermal signature. The heat distribution matched the body, rotating with mechanical precision, not an irregular chunk of ice tumbling through space. Every 6 hours, the light curve repeated itself with remarkable consistency. Principal investigator Dr. Sato characterized the rotation as uncannily steady for an object this size. NIR spec, the telescope's near-infrared spectrograph, scanned for traces of volatile compounds. The spectra revealed a coma dominated by carbon dioxide, but the signal appeared diffuse, no concentrated plumes, no sudden bursts. The nucleus reflected light with that same crisp, metal-bright quality, echoing ground-based suspicions of an unusually smooth or possibly faceted surface. Yet despite this brightness, there existed no evidence of outgassing powerful enough to alter the orbit. Precision astrometry became the ultimate test. Over 2 months, the James Webb Space Telescope and ground-based observatories tracked 3I/Atlas's position to within milliarc seconds. The result: any non-gravitational acceleration, whether from jets, radiation pressure, or something more exotic, measured smaller than 1/10,000,000th of a meter per second squared. In practical terms, the object moved as if gravity alone governed its path. No measurable drift, no unexplained thrust. As Dr. Sato summarized, if there's an engine aboard, it's quieter than anything we've ever encountered. Dr. Avi Loeb's checklist for artificial origin reads like a forensic protocol. Unexplained acceleration, extreme reflectivity, absence of outgassing, and a shape or rotation pattern that defies natural formation. The international consortium studying 3I/Atlas mapped each observation against this framework. No measurable non-gravitational acceleration. JWST and ground-based teams established the upper limit more precisely than for any previous interstellar visitor. The reflectivity is high, though not entirely without natural precedent. Outgassing is present, albeit subdued. The rotation remains regular, showing no erratic behavior or signs suggesting engineer control. Each criterion demands precision data, yet raw astrometry and spectroscopic results sometimes remain behind brief embargoes, fueling public debate. Officially, most data releases follow standard peer review cycles, days, not months. However, in a case this unprecedented, every hour delay invites scrutiny. A process designed for scientific rigor can appear like opacity when the entire world watches. 3 interstellar visitors, 3 distinct narratives. Oumuamua, the first, raced through our system with no visible tail and geometry that defied every known classification, then elongated, accelerating for reasons no one could definitively establish. Borisov arrived as a classic comet, venting gas and dust precisely as theory predicted, yet moving faster and burning brighter than anything originating from our own cosmic neighborhood. Now 3I/Atlas blurs these boundaries. It carries an extensive coma like a comet, yet its nucleus shines with a brightness and symmetry suggesting something unprecedented. Astronomers describe it as a hybrid, neither conventional comet nor typical asteroid, but evidence that the galaxy's inventory is far more diverse than textbooks acknowledge. Each encounter expands our understanding, raising the stakes for how we search and how we interpret what we find. The next radar observation, scheduled for perihelion in late October, could reveal structural details or motion patterns previously missed. Until then, the world remains watchful, waiting to discover if this visitor will rewrite the rules once more. As of this account, the object's true nature remains undetermined. What stands beyond question is that each new interstellar visitor tests the boundaries of our detection capabilities and analytical methods. For now, 3i/Atlas exists simultaneously as a profound scientific puzzle and a stark reminder that the search for answers depends on transparent data sharing and global collaboration. The cosmos has sent us a messenger. Understanding its message may be our next great challenge. October 28, 2025, 1422 Universal Time Coordinated. The Era Seaboard Replacement Deep Space Radar Array in Puerto Rico locked onto 3i/Atlas as it reached its closest approach to the Sun. This was the moment astronomers have been waiting for: maximum resolution, optimal positioning, and 4 full months of preparation. Dr. Sarachin stood in the control room, watching 3 massive screens simultaneously. The first displayed raw radar returns. The second showed real-time spectroscopic data from the Gemini Observatory. The third tracked communication feeds from 17 facilities across 6 continents, all focused on this single object. Radar contact confirmed. The technician announced, "Beginning surface mapping sequence." The room fell silent except for the rhythmic pulse of cooling systems and the soft clicking of keyboards. What appeared on the primary screen in the following 90 seconds would be discussed for generations. The radar return painted a picture that made no sense. The nucleus wasn't just smooth. It showed geometric regularities at multiple scales. Flat sections intersected at precise angles. The rotation, tracked now with unprecedented accuracy, revealed something that made Dr. Chen's breath catch in her throat. The object was tumbling, but its tumble rate was decreasing. "That's impossible," muttered Dr. James Rodriguez from MIT, who had joined via video link. "Nothing natural dampens its own rotation in deep space. There's no atmosphere, no tidal forces at this distance. Unless it's doing it intentionally," Dr. Chen said quietly. The spectrographic data from Gemini arrived moments later. The carbon dioxide signature that had dominated earlier observations was changing. New emission lines appeared in the infrared, complex organic molecules, far more diverse than any comet should produce. And there was something else, a periodic signal in the radio spectrum, faint but unmistakable, cycling every 6.2 hours. "Is that structured?" someone asked. Dr. Chen pulled up the analysis software. The signal wasn't random noise. It carried patterns, repetitions, variations, mathematical sequences. Prime numbers appeared in the intervals. Fibonacci sequences emerged in the frequency modulations. "We need to isolate this," she said, her voice steady despite her racing heart. "Cross-reference with every natural radio source we know. Pulsars, magnetars, every anomaly in the catalog." The team worked through the night. By dawn, they had their answer. The signal matched nothing in nature. It was artificial. But it wasn't a message directed at Earth. It was something far more disturbing. October 29th, 2025, 6:15 Universal Time Coordinated. Dr. Chen convened an emergency video conference with the International Astronomical Union's Crisis Response Team. Faces from NASA, ESA, CNSA, and JAXA filled her screen, all showing the same mixture of exhaustion and disbelief. "The signal isn't a transmission," she began. "It's a diagnostic sequence. 3i/Atlas is running systems checks." The implications hung in the digital silence. Dr. Rodriguez continued the briefing. "We've analyzed the rotation damping. It's using controlled gas venting. So precise it creates virtually no detectable thrust, but enough to stabilize its orientation. The geometry we're seeing in the radar returns matches predictive models for a multi-layered structure, an outer shell of ice and organic compounds, approximately 2.3 meters thick, covering something denser underneath. You're suggesting, the NASA administrator started. We're not suggesting anything, Dr. Chen interrupted. We're reporting observations. But those observations are consistent with a manufactured object disguised as a comet. The Webb Space Telescope had captured one final, crucial piece of data during a targeted observation window. Deep within the infrared spectrum, buried beneath the thermal signature of sun-warmed ice, there existed a cold spot, a region that absorbed heat rather than radiating it, as if something beneath the surface was drawing energy. It's not just passing through, Dr. Chen said. It's recharging. Over the next week, 3 more discoveries emerged that transformed speculation into something approaching certainty. First, archival analysis revealed that 3I/Atlas's trajectory wasn't random. When astronomers traced its path backward through the galaxy using stellar motion data, they found it had passed within 0.3 light-years of 17 solar systems over the past 400,000 years. Every single one a G-type star like our Sun, and every single one recently confirmed to host planets in the habitable zone. Second, the Breakthrough Listen project, searching for extraterrestrial intelligence, detected the same diagnostic signal pattern in archived data from Oumuamua. It had been there all along, dismissed as instrumental noise because no one thought to look for it in that specific frequency range with that particular filtering algorithm. Third, and most chilling, amateur astronomer Marcus Webb in New Zealand noticed something while reviewing his backyard telescope footage. In the week since perihelion, 3I/Atlas's brightness had decreased. Not gradually, as expected from increasing distance, but in a stepwise fashion, for distinct drops, each occurring exactly 6.2 hours apart. It was shedding its outer layers. November 4th, 2025, present day. 3I/Atlas now races outward past the orbit of Mars, accelerating slightly faster than orbital mechanics alone would predict. The diagnostic signal has ceased. The tumbling has stopped entirely. The object now maintains a stable orientation, one face. The face we cannot see, hidden by the ice, pointed perpetually toward a galactic core. Dr. Chen's final report to the international scientific community contained a single recommendation. We should consider that 3I/Atlas and its predecessors are not visitors in the traditional sense. They are surveyors. The question we must now ask ourselves is not what are they, but rather what happens when they report back. In the constellation Sagittarius, 25,000 light-years away toward the galactic center, something received a signal it had been waiting for. It would take millennia for any response to traverse that vast distance, but in the cosmic scale of time, millennia pass like heartbeats. The night sky above Earth looked the same as it always had. Stars twinkled in their ancient patterns. Planets traced their predictable paths. But humanity now knew with unsettling certainty that someone, somewhere, was watching back. 3I/Atlas crossed the orbit of Jupiter 3 weeks later, its ice shell completely shed, revealing nothing. Long-range observations showed only darkness where the nucleus should be, something so black it absorbed 99.8% of incident light, visible only as a void against the background stars. And then, at the edge of detectability, it simply vanished. Some said it had finally moved beyond the range of our telescopes. Others suggested its active camouflage had engaged now that the performance was complete. Dr. Chen had a different theory, one she shared only with her closest colleagues in quiet hours after midnight. It didn't disappear. It transformed. Whatever it was pretending to be, it's done pretending. The search for interstellar object 4I has already begun. Every telescope, every detection network, every amateur astronomer with a clear view of the sky now watches and waits. Because 3I/Atlas taught humanity an uncomfortable truth. We are not alone in the universe, and we may never have been. The visitors have been coming for a very long time. The only question remaining is, what will they do with what they've learned? November 15th, 2025. The emergency session of the United Nations Security Council was unlike any in history. For the first time, the topic wasn't war, terrorism, or pandemic. It was contact, or more precisely, the implications of confirmed surveillance by an unknown intelligence. Dr. Chen sat at the witness table, flanked by representatives from every major space agency. Behind closed doors, she had already delivered the classified briefing. Now, with select details approved for public disclosure, she faced the cameras and chose her words carefully. 3I/Atlas has fundamentally altered our understanding of our place in the cosmos, she began. We are not announcing contact with extraterrestrial intelligence. We are announcing evidence of sustained long-term observation by what appears to be autonomous reconnaissance technology. The questions came rapid fire. How long have they been watching? What do they want? Are we in danger? Dr. Chen could only answer honestly. We don't know. What she couldn't say publicly, what remained sealed in classified annexes, was far more unsettling. The signal analysis had revealed something else. Embedded within the diagnostic sequences were packets of compressed data, terabytes of information being transmitted outward in tightly focused beams. The target of those transmissions, a region near Sagittarius A*, the supermassive black hole at the galaxy's center. Humanity had been cataloged, measured, and reported, and whoever built these probes had chosen to position their civilization, or whatever they had become, at the very heart of the Milky Way. December 2nd, 2025. Dr. Jian Wei, lead analyst of the Breakthrough Listen SETI program, hadn't slept properly in weeks. His team had been systematically reanalyzing decades of radio telescope data, searching for the same signal pattern found in 3I/Atlas. At 3:47 a.m., the algorithm flagged something in observations from 2017, data collected while studying Proxima Centauri, our nearest stellar neighbor. The pattern was there. Faint, fragmentary, but unmistakable. Something had passed through the Proxima Centauri system 8 years ago, running the same diagnostic sequence. But this wasn't the shocking part. The shocking part was what came next in the data stream, a response. From the surface of Proxima Centauri b, the potentially habitable planet orbiting that red dwarf star just 4.2 light-years away. Something had answered the probe signal. The exchange lasted 17 minutes. Then silence. Dr. Wei stared at the waterfall display, his hands trembling. Proxima Centauri had been flagged for years as potentially habitable, but most scientists considered it unlikely to harbor complex life due to stellar flares and tidal locking. Yet here was evidence of technology, of intelligence, of response. Either Proxima b was inhabited, or someone had gotten there before us. He reached for the phone to call Dr. Chun, then stopped. This discovery would change everything, again, and it raised a terrifying new question. If the probes were surveying multiple civilizations, were they simply observing, or were they coordinating something larger? December 18th, 2025. The leak came from an anonymous source within the China National Space Administration, posting encrypted files to a darknet astronomy forum. Within hours, the scientific community was in chaos. China's Tongwen 4 Deep Space Monitoring Array, operational since 2023 but largely classified, had been tracking something else, something the Western observatories had missed entirely. The leaked data showed not 3 but 7 interstellar objects detected over the past 15 years, all following similar trajectories, all exhibiting the same anomalous characteristics. But one entry in the leaked database made headlines around the world. Object 5I/Tianwan-4 Alpha, detected in March 2024, hadn't left the solar system. Its trajectory had shown a subtle deceleration maneuver near Jupiter, and its last confirmed position placed it in the asteroid belt, moving at a velocity consistent with orbital insertion. Something was still here, watching, waiting. The international response was swift and fractured. Some nations demanded immediate disclosure of all classified space surveillance data. Others doubled down on secrecy. The European Space Agency announced an emergency mission, a high-speed probe to investigate the coordinates where 5I was last detected. Dr. Chen received the coordinates through a secure channel, along with a note from Dr. Wei. The signal patterns match. All 7 objects. They're not random probes. They're a network. And I think they're building something. January 8, 2026. The crew of the International Mars Base, humanity's first permanent settlement on another world, had been conducting routine geological surveys when seismometers detected something unusual. Rhythmic vibrations, too regular to be natural, originating from deep beneath Valles Marineris, the largest canyon in the solar system. Commander Lisa Torres reviewed the data with growing unease. The vibrations occurred in pulses, prime numbers again. 2, 3, 5, 7, 11, 13, repeating every 6.2 hours. "It's calling to them," she whispered, pulling up orbital tracking data. Or, they're calling to it. The Chinese revelation had included trajectory analysis, showing that multiple interstellar objects had made close approaches to Mars over the past century, and Valles Marineris, formed billions of years ago by geological forces, was also one of the deepest accessible points on the Martian surface. What if the probes hadn't just been surveying? What if some had been deploying? Torres sent an encrypted transmission to Earth, flagged for immediate attention. Request emergency authorization for Deep Canyon expedition. We need to know what's down there. And we need to know before something wakes up. January 15th, 2026, 8:33 Universal Time Coordinated. Every radio telescope on Earth registered it simultaneously. A pulse of coherent radiation, lasting exactly 6.2 seconds, emanating from multiple points across the solar system. The Arecibo array triangulated 7 sources. The 7 interstellar objects, all transmitting in perfect synchronization. Dr. Chin was in Geneva, presenting to the United Nations Space Command Coordination Committee. When the alerts flooded in, the room erupted into controlled chaos, officials shouting into phones in a dozen languages. The transmission wasn't directed at Earth. It was directed outward, toward Sagittarius A*, compressed into a tight beam that would take 25,000 years to reach its destination. But the 7 objects weren't just transmitting, they were also receiving. High-gain antennas at the Very Large Array detected incoming signals, not from the galactic core, but from somewhere much closer. Triangulation placed the source at approximately 1,200 light-years away, in the direction of the Kepler 442 system. The signal had been traveling for over a millennium. Whatever sent had launched its message around the year 800 AD, when Charlemagne ruled Europe and the Tang dynasty flourished in China. The content of the message remained encrypted, far beyond human capability to decode. But the metadata was clear. It was a command sequence, an activation protocol. Dr. Wei's voice crackled over the emergency conference line. They're not just probes. They're nodes in a communication network spanning thousands of light years. And someone just turned it on. January 20th, 2026. In a bunker beneath Geneva, representatives from every spacefaring nation gathered in absolute secrecy. The data was irrefutable. The implications were staggering. Humanity faced a choice that would define its future, perhaps its survival. Option 1. Attempt to communicate. The network was active. The probes were still within range. Humanity could send its own signal, announce its presence, seek dialogue with whatever intelligence had created this vast surveillance apparatus. Option 2. Remain silent. Continue observing, learning, preparing. Hope that humanity's primitive radio leakage had gone unnoticed, that Earth was just one data point among thousands in an ancient survey, not yet flagged as significant. Option 3. Interfere. The probe in the asteroid belt was within reach. A targeted mission could capture it, study it, potentially disable it before it completed whatever function it was designed to perform. Dr. Chin stood before the assembly, exhausted, terrified, but oddly hopeful. For 200,000 years, humanity has looked at the stars and wondered if we're alone. Now we know we're not. We know we've been observed, cataloged, connected into something vast and ancient. The question isn't whether to respond. It's what kind of species we want to be when we do. She pulled up the final slide of her presentation. A composite image showing Earth from space, overlaid with the detection points of all 7 interstellar objects, their trajectories forming a pattern around our world like points on a sphere. They've been watching us for at least 15 years, probably longer. They've mapped our civilization, our technology, our biology, and they've done the same to dozens, maybe hundreds of other worlds. This network spans a galaxy. We can't hide anymore. We can only choose how we want to be known. The vote was scheduled for dawn. Outside, across the world, Millions looked up at the night sky with new eyes, knowing that somewhere in that vast darkness, ancient minds were watching, calculating, deciding. And in the asteroid belt, something that had slept for decades began to unfold. January 21st, 2026, 6 o'clock Universal Time Coordinated. The decision was made. Humanity would respond. Dr. Chen stood in the control room of the upgraded Arecibo Deep Space Array, her hand hovering over the transmission authorization key. The message had been crafted carefully: mathematical proofs, chemical diagrams, a primer on human biology and culture, encoded in the same format the probes themselves used. But she hesitated. Once sent, there was no taking it back. The message would propagate across the network, reaching nodes throughout the solar system, then leap outward toward whatever lay 1,200 light-years away in the direction of Kepler 442. In 1,200 years, something would hear humanity's voice for the first time. Or perhaps, and this thought made her blood run cold, something had been waiting for humanity to announce itself, to confirm our presence, to volunteer a location into some vast cosmic database. Dr. Chun, the technician said softly, "We're at T-minus 30 seconds. Through the window, she could see the massive array turning, orienting toward the calculated position of Object 5I in the asteroid belt, the nearest node, the first recipient of humanity's message. 20 seconds. Her phone buzzed. A message from Commander Torres on Mars. Canyon expedition reached depth marker 4.2 kilometers. Found structure. Definitely artificial. Definitely old. And it's responding to your countdown. Whatever you're about to do, I hope you're right. 10 seconds. Dr. Chin thought of all the civilizations that might have made the same choice, standing at the same threshold, deciding whether to step out of the shadows and announce themselves to the cosmos. How many had chosen silence? How many had chosen to speak? And how many were still there to regret their decision? 5 seconds. She pressed a key. The transmission burst forth, carrying humanity's first intentional message to an alien intelligence, encoded in protocols we had learned from watching them watch us. For 6.2 seconds, the array broadcast at maximum power. Then silence. Across the solar system, the 7 probes received the message simultaneously. One by one, they began to respond. And on Mars, for kilometers beneath the surface of Valles Marineris, something vast and ancient opened its eyes for the first time in 50 million years. The age of isolation was over. The age of contact had begun. And no one, not Dr. Chun, not the assembled government of Earth, not even the ancient intelligence that had seeded the galaxy with their mechanical children, could predict what would come next.